Hi math students, it's Miss Carol here, and we are on Unit 3, Lesson 13. In Lesson 13, we've only got 4 questions, so hopefully this will be a little quicker. We are still on the models and scale models that are constructed in real life for redesigning a local community center. So let's jump in here. Question 1. Raphael and Morgan are painting a model of a new community center to be displayed at the next city council meeting. Working together, they can finish the project in 4 hours. Working alone, it would take Morgan 6 hours longer than it would take Raphael. Their hourly production rate can be represented by the equation 1 over r plus 1 over r plus 6 equals 1 over 4. So remember, this is the hourly production rate. If it takes them 4 hours together, then hourly would be 1/4. And Morgan takes 6 hours longer than Raphael, which is where we get that r plus 6. Okay. To do this, let's see. So what we need to do, let's see. So to figure this out, we need to begin by multiplying each denominator through the equation to cancel them out. And this is exactly what we did in the previous problem, but we're going to do it all in one step until we end up with a standard form of a quadratic equation. So I think the first one we'll do is we will go ahead and we will multiply r plus 6 through each of these terms. So we have 1 over r, and we're going to take r plus 6. Remember, each denominator, we're trying to get rid of each denominator, and the way we do that is multiplying everything through by each denominator. So r plus 6, and then we've got r plus 6 times 1 over r plus 6 equals 1 times r plus 6 over 4. Okay, so now these go away and we're just left with 1 here. So we have r plus 6 over r plus 1 equals r plus 6 over 4. Okay, now I'm going to go ahead and multiply through by r. R, and r. Okay, when I do that, the r's cancel out here, and I get r plus 6 plus r equals r plus 6 times r over 4. Now I'm going to multiply everything through by 4. To get rid of that last denominator. And when I do that, the 4's over here cancel out, and I get, let's do it right here, 4r plus 24 plus 4r equals r plus 6 times r. Okay. Now remember, I need to distribute through, okay, and combine some like terms. So 4 plus 4r is going to give me 8r plus 24 equals r squared. R times r is r squared plus 6r. I like my r's, or my a value in my standard equation, to remain positive, so I'm going to subtract 8r from both sides, and I'm going to subtract 24 from both sides. Okay, when I do that, I get 0 on the left equals r squared minus 2r minus 24. And when I type it in, I'm just going to switch these around so that I have the 0 on the right. Okay, so this will be r squared minus 2r minus 24 equals 0. Okay, that was kind of quick. If you need to rewind this or watch it a couple times to really get the hang of how I did that, that's totally fine. That's the beauty of the recording. Let's go ahead and scroll down. Solve the equation from the previous answer by completing the square. Okay, so we've now moved on to completing the square. All right, so I'm going to erase this so we have some room to work. If you'll remember, standard form of the quadratic equation, let's see. So we didn't get a negative a, so we don't need to multiply by -1. But so we're gonna end up with two terms here, and I just wanted to make sure that they didn't want the factors, they indeed want the solutions. So we've got r squared minus 2r minus 24. Ax squared plus bx plus c equals 0 is our standard. Okay, so the first thing that we're going to do when we complete the square is we're going to move that c value over to the other side. So we're going to say that r squared minus 2r equals a positive 24, okay? Now we are going to, this is the true completing the square part, we're going to take half of our b value, so b over 2, and we're going to square it. So b is -2 divided by 2 squared. That's just -1 squared, which is a positive 1. I am now going to add that to both sides of this equation, and that is going to allow me to complete this square. Okay, so I'm going to have r squared minus 2r plus 1 equals 24 plus 1 is 25. Oh, look at that. All right, so now I know that my factors of this are going to be simply that b value, or that b over 2 value. So it's going to be r minus 1 times r minus 1 equals 25. Okay, this is where this comes in really handy. These are always going to be the same when you complete the square. So you can say r minus 1 squared equals 25. Now, what we can do is we can take the square root of both sides. When you take the square root of something squared, you end up with the base. So the square root of r minus 1 squared is simply r minus 1. The square root of 25, hopefully we all know, is plus or minus 5. This is where we're going to come up with two answers. So we now know that r minus 1 equals 5, or r minus 1 equals -5. Okay? I'm going to add 1 to both of these. So r will be equal to 6, because 5 plus 1 is 6. Or r will be equal to -4, because -4 minus 1 is -5. So our answers are going to go in here like this. Completing the square, you have to remember to take it step by step. The first step, of course, is moving that c value over to the other side. The second step is taking half of your b value. The third step would be squaring that, then adding that squared value back to both sides, and then factoring. The left side is easily factorable. What we do when we add that squared value back to both sides is we essentially make the left side of that equation very, very easy to factor. Your factor becomes b over 2. And then hopefully the right side is easier to factor. It's not always easier, or easy to take the square root of is what I meant to say. It's not always a perfect square, but in this case it ended up being 1. So again, our values are 6, negative 4. All right, and our last, well, actually, probably we've got 2 more questions here. Let's erase all this and write a step-by-step description of how we got to the solutions we identified in that problem. I'm going to help you out with this because I think it's important that we're understanding how to complete the square. So the first thing we did was we moved the C value of negative 24 to the other side of the equal. Okay, the second thing that we did was take b over 2, negative 2 over 2, negative 1. The third thing we did was square negative 1. Fourth thing we did was add 1 to both sides. Fifth thing we did was factor the left side to r minus 1. And then that was squared. And then last but not least, well, not last, we took the square root of, and we're going to set that equal to both sides. So r minus 1 equals square root of 25, which equals plus or minus 5. And then here's the last thing. Found solutions by setting r minus 1 equal to plus 5 and r minus 1 equal to minus 5. And then we solve for r. Okay, so I do best with completing the square when I think of it as a very, very step-by-step process, and hopefully you guys can benefit from that as well. All right, now the last question. How long will it take Morgan to complete the answer on her own? Remember, Morgan equals r plus 6. Okay, well, we have 2 answers for r. We have a negative 4 and we have a positive 6. Negative 4 can't work because we can't operate in negative time. So we know that r equals 6 because negative 4 is negative time and is not a viable answer. So Morgan equals 6 plus 6, which is 12 hours on her own. Okay, hopefully that makes sense. And thank you for sticking with me. It took a little bit longer, but completing the square is definitely a little bit harder. So I will see you back here for lesson 14.